Okay, I think we are going to get started. So head over and let's begin. So, welcome to September, London Gophers. We are back once again. Took a short break in August, but I hope the new raffle prizes that are coming up will make up for that. And we're just gonna get going and get cracking on. So this is going to be the agenda for this evening. We have this quick welcome, then we have Grayson Hardaway, and then we're going to have a quick break on our classic conundrum, and then we're going to have deep data coming up talking about security, and then we'll do a nice little closing section where we will have one more, we'll have a raffle for a Switch, which is a pretty cool prize. And yeah. So always open for new speakers, lightning talks, usually 10 minutes, regular talks around 30 minutes or so. Feel free to send us in your ideas, and any topic is welcome, and we're always willing to help out and help with any presenting and or putting things together if you want as well. And so yeah, feel free to email us and let us know. So these are just a few ideas that you could go with, but once again, open season, always open to ideas. So our first talk is going to be Grayson Hardaway talking about Beyond Gosec, detect complex code patterns using semantic grep.
Okay, so should I get started?
Yep.
All right, let me present and let me share screen. Yes. All right. There we go. Somebody who has visuals, can you confirm that things are shared, visible, all that? Sweet, thanks for the thumbs up. All right, cool. All right, hello everyone. Thank you for having me. I'm coming to you live all the way from the USA, in California, where finally, I don't know how much you've followed it, but the fires have died down and we can actually see the sun again, which we haven't been able to for about 2 weeks. So I'm thrilled to have shining light behind you. Anyway, thanks again for having me. My name is Grayson, and today I'll be talking to you about going beyond Gosec, detecting complex code patterns using semantic grep. So I have the stream chat pulled up. So if you chat some questions in there, I will be doing my best to pay attention to it and answer them as we go. Without further ado, let's get started. So the too long didn't watch of this talk is that writing secure code is hard. Static analysis tools are typically noisy or slow. grep isn't expressive enough to find what you want in your code. And so we need something that's fast, code aware, flexible, powerful, and open source, which is semgrep. So semgrep stands for semantic grep, and it is a fast, syntax-aware semantic code pattern search for many languages, which is a huge mouthful to say. And so an easier way to think of it is that it's like grep, but specifically for code. So you can use semgrep to do all manner of different things: search your code, find security bugs, guard your code. You can use it in CI to enforce specific patterns or best practices. You can use it to migrate off of old or deprecated APIs as well, which I'll demonstrate a little bit later. A little bit about me. My name is Grayson. I'm a security engineer at R2C. In a past life, I used to work for the US Department of Defense, doing all manner of interesting things. But now I work for R2C, which is a San Francisco-based startup. We do static analysis, and we're on a mission to profoundly improve software security and reliability. So this is a shot of the team down here on the right. And so I wanted to take a second to just recognize that everything that you see here would not be possible without the help of the entire team. So they're a great team to work for. R2C is great. And everybody here has had an instrumental contribution to what you're going to see here today. So special shout out to all of them, and thank you to them. A quick outline of the talk. We'll go over some background of semgrep first. We'll talk about why grep isn't necessarily always the best choice for searching code. And then we'll do a lot of semgrep examples back to back to back. And then I'll close with talking about how you can integrate semgrep into your CI. And then a little bit about a rules registry that we maintain. So as I mentioned at the beginning, semgrep is open source, and so you can navigate over to our GitHub page and check it out. You can browse the code. The core of SemGrep is written in OCaml, and then there's a Python wrapper around the outside for all of the command line niceties. So you can clone it, you can read it, you can contribute to it if you want, and yeah, it's all there on GitHub. SemGrep actually has a long history of being open source. It was originally written at Facebook in 2009, so over 10 years ago, and was used there to enforce nearly 1,000 rules. The original author, who is pictured here, Johan, works for R2C now. He joined us last year and was the first static analysis hire at Facebook, has a PhD from INRIA, and was a contributor to Coccinelle, which was the predecessor to SemGrep. It looks very similar, but it was specifically for the C language. SemGrep supports a lot of different languages, to include Go, of course. We also have support for Java, JavaScript, JSON, Python, and then we have betas out for Ruby and JSX, alphas for C and OCaml, and we are adding TypeScript support this month. And we've got a few more in the queue as well after we add TypeScript. Cool, so that's a little bit of background. Let me talk now a little bit about grep and abstract syntax trees. So if you have a code base, you've inherited it, or you join a new company, and you want to search through that code for something specific, it's perfectly reasonable to turn to regular expressions to get an idea of what you're looking at or what you're looking for. But this is the classic XKCD comic of if you use regular expressions, then regular expressions becomes one of your problems that you now have to deal with. And the reason for that, when you use grep or regular expressions when applied to code, is that fundamentally code is not a string, it's actually a tree. So if you harken back to compilers class or programming languages class, if you ever took that, you know that in the process of compiling down code, it goes from a string into what's called an abstract syntax tree. And there's kind of a graphic there on the right. And so there exists a lot of tree matching tools, to include Gosec, the security checker for Go. Others include Bandit for Python and ESLint. But some downsides to that are that if you want to use these AST matchers or these tree matchers for your language, you have to learn the AST for that language. And then you also have to know the syntax of the language that you're working in. Further, like the ability to write new rules using these tree matchers has a barrier to entry, because you have to think about your code as a tree, which is not actually how we think of it, but it is how the compiler thinks of it. And so if you don't really want to write all these yourself in an AST matcher, you can turn to commercial tools. But traditionally, these are a little bit cumbersome. So they don't play very well with like external ecosystems. They're not really up to date for modern CI/CD pipelines. They tend to be a little bit slow, so they can take on the order of hours or even days to like complete and present results. And of course, if you're doing a commercial tool, then they cost money. So to sort of put this into perspective, Instagram released this article a little over a year ago now that has this cool chart that explains exactly this, which is on the left, you have regular expressions, which are easy, but they're very dumb. If you use them for code, you can match things like comments or string literals or documentation files, which you may not want. And then on the right, you have whole program analysis, which is powerful but complex, takes a while to set up, and might not play super well with your with an Agile continuous integration environment. And so SemGrep lives somewhere in the middle between the two, where we have like an easy interface that looks a lot like the code that you're familiar with, rather than having to learn like a complicated domain-specific language, which you typically have to do on the whole program analysis side. But SemGrep also doesn't do whole program analysis yet. Instead, we focus on the unit of individual files. And so what we lose in complexity, we make up for in speed and ease of use. And so the fundamental insight that SemGrep has is that SemGrep lets you reason about your analysis the way you reason about your code. So As I mentioned, it has a syntax that looks very similar to the code that you're writing, which I will now begin to demonstrate. So I'm going to make my way through a bunch of these demos. They will be live. Hopefully they work. And so the sort of outline of these demos is this. The first three I'm going to show you are the basic fundamental operators of semgrep. And so the first one is going to be the ellipsis operator. Then I'm going to talk about metavariables, and then I'm going to talk about composing patterns together to get what you want. And then I'll talk about some other things after that. So let's do like a scenario-based example. So let's say you are an engineer, software engineer, or a security engineer at a company, and you have just had a mandate come down that says you are now no longer allowed to use RC4 in your code base. You have to eliminate it from your code. And so what you have to do first is you have to search your code for everywhere that RC4 is used. And these are some examples of what it may look like in your code. And we can use semgrep to identify a lot of these things. So I'm going to click on this link here, which will take us over to a live editor that we built, inspired by like regular expressions 101. If you've ever used that, you can type in your pattern and type in some stuff that you want to match and see where it matches and stuff like that. So that's kind of the inspiration of this. And so it's the same thing here. Up here in this pane, the top left is will be your semgrep pattern, and down here is the sample code that you want to check. And so as you can see, we have a couple of examples that for RC4 that we want to check, to include some that we don't want to find, which is like this comment and this string literal. So as I mentioned, the interface for semgrep looks and feels a lot like code you're writing. And so what we can do is literally just copy some code that we want to match and paste it up here in our pattern pane. And then if we click run, we will run and see what it matches. And so right away, we see that we matched rc4.newCipher with key, where key is the argument name, which is cool. We can see that we don't match the comment. We don't match the string literal. And that we also match this pattern, which has white space in it. And so you can immediately see the advantage over grep right away, because grep would have trouble with this. You would have to match white space. It doesn't match the comment, and it doesn't match the string literal. And so what semgrep does under the hood is it parses the code into an abstract syntax tree, and it parses your pattern into a similar abstract syntax tree, and then tries to match on that rather than using strings. The one match that we didn't get is this one here, which is has another name for the argument to the function. And so what we can do is use the ellipsis operator to abstract this away. The ellipsis operator abstracts away sequences of things. And so this might be parameters, it might be arguments, it might be entire statements. And effectively, it's like dot star in regular expressions. But you can also think of it as saying, like, I don't really care what's in here. So if we use the ellipsis operator, which is 3 dots, then effectively we're saying rc4.newCipher with anything inside, which is exactly what we want to match. And we will see that we now pick up this other match here, which is awesome. So mission accomplished. We've now found all of these rc4.newCiphers. Similar example, let's say a mandate has come down. Oops. Let's say a mandate has come down and you are now no longer allowed to use anything from the unsafe package. And so unsafe.pointer, size of, anything like that. As the name implies, it is unsafe, or at least it bypasses a lot of the safety mechanisms that Go provides. And so we just want to check to make sure that it's not in our code. And if it is, ask why. But anyway, we'll jump over to another example. And so the 3 examples that we want to detect are this one, unsafe.pointer, unsafe.sizeof, and unsafe.pointer again. So as before, we can copy some code in here and click run just to see what we get. And as before, we see that we get the literal of the code pattern that we typed. But we also want to catch this one, unsafe pointer, with a different name. So we can use the ellipsis again to abstract that away. And we'll match that one. But we're still missing this one, which is unsafe.sizeof. And so your first intuition might be to do something like this, which is another ellipsis. But the issue there is that with arguments, you can actually have like 0 or more of these. And so the semgrep pattern has to be valid code in the language that you're working in. And so because there has to be a function name attached to this after the dot operator, what we have to do is use something called a meta variable instead. And so a meta variable you can think of similar to a capture group in regular expressions, but what it's actually doing is it's like abstracting away a whole section of the abstract syntax tree underneath. And so in this case, it would be the function name. And so the meta variable syntax in semgrep is it starts with a $, and then is all capital letters. And you can use any name, just like you can use any variable name, you can use any meta variable name. And by doing this, we're basically saying, find me everything that is unsafe dot something with any number of arguments here. And so that's what this pattern will check or will detect. And now we will see that we have all 3 of our matches. As I mentioned before, I get this question a lot at this point. You can do any name here and it will still match. So you can see that the meta variable, the name is irrelevant. It just has to be $ with all capital letters. All right, so the last sort of basic example that I want to talk about is composing patterns together. So in this scenario, what we're going to be trying to find are TLS configurations where the minimum version of TLS is SSL 3.0, which is known to be broken. There are many attacks that are trivial to conduct on SSL 3.0. And so what you really want to be using at this point is TLS 1.2 or above. 1.3 is out and I think available in Go. And then we also want to find TLS configurations that might have this insecure skip verify flag set to true. And what that says is don't verify the identity of the server that you're checking, which means you could be connecting to a malicious server. Oops. So if we jump over to this example, switch anyway. Yep, okay. We can see that this has already been filled in. So we're looking for TLS configurations where the minimum version is SSL 3.0, which is what we find here. But we also want to detect this TLS configuration down here where the version is okay, but insecure skip verify is set to true. And so if you say it in English, what we want to detect is a configuration where the minimum version is not sufficient, or insecure skip verify is set to true, which immediately starts to sound like logic, which is what you can do up here. So we have the ability to compose patterns together in the graphical editor, or whatever you want to call this. You can add the plus button for a new pattern that you want to detect. And then we have these logic operators in here where you can compose patterns together. So as I said earlier, what we want to detect are configurations where we have one condition or another condition. And so we're going to use this or is, and then copy this and detect the second condition that we want, which is insecure skip verify set to true. And when we run this, we should see that we now detect this second one as well. And so this is an example of composing patterns together to get either to cast a wider net, or you can also use patterns to sort of filter out cases that you don't want as well. So those are like the basics. Just a quick reminder, ellipsis abstracts away sequences of things. Meta variables abstract away. It's kind of like saying something goes here, but I don't know what it is. It could be a name. It's usually a name. And then the third thing is that you can compose patterns together. So all of the examples that I've given so far have been security examples, but you can also use it to enforce, like if you have a coding standard in your organization, you can do something like that. And so this is an example that I found a long time ago in a blog post about Go anti-patterns. And so the anti-pattern ostensibly here is, it's called a hidden Go routine. And so this function cleanup, the only thing it does is it calls Go on this anonymous function. And so the reason this is considered an anti-pattern according to the blog post is that it breaks the developer expectations, because when you call cleanup, when another developer comes along and calls cleanup, it's not clear that you're invoking concurrency. And so the better option is to not do that and to explicitly call Go on your function. Oops. which is much clearer. And so I just want to jump in here and show that this is a thing that you can detect. So here's hidden Go routine. The only thing this function does is call Go on this anonymous function, whereas this one has like some code, and this one has some code, and that's fine because that's expected. You can also enforce business logic with semgrep. And so let's say that you are in a financial company where the API that you've inherited is not that great. And so this one, this API requires you to call verify transaction before you call make transaction. So, don't make unverified transactions. This is not super great design, but sometimes it exists and sometimes it's what you have to deal with. And so if you wanted to, you could enforce this, you could enforce having verified transaction happen before make transaction using semgrep. And so the pattern here is find me all functions with make transaction inside of it, and then filter out and is not functions where verified transaction occurs before make transaction. And so if we scroll down here, we can see this function only has make transaction in it, which is cool. That's bad. We can see that verified transaction happens after make transaction, which is also bad. You can see the ellipsis operator has abstracted away sequences of statements. And so it's basically saying, I don't care what code is between here and there. And so that's what this is demonstrating. And again, verify is called after make, which is bad. Verify is called before make, which is good. And then this last example, something that I didn't mention earlier about meta variables is that they are enforced to be equivalent. So in the same way that if you reuse a variable in your code, you expect it to be the same, pending no side effects. Meta variables are the same. And so if you reuse a meta variable name, they are expected to be the same. And so the issue with this last one is that it's actually an example that we want to detect, like we want it to match or be highlighted. And the reason for that is because verified transaction is called before make transaction, which is exactly what our pattern detects. But the transaction that's being verified is actually the wrong transaction. So you can see here we have this other and then make transaction on T. And so what we want to do is reuse a meta variable that says what we actually want to filter out. We want to find all functions with make transaction in it. And then we want to filter out anything that where verified transaction is called on a transaction, and then a make transaction is called on the same transaction. And so this will allow us to highlight this last example, which works, which is cool. I'm watching time, so I want to go through these last examples relatively fast. So one thing that's cool is you can interpolate meta variables into the message of your finding. So up here, there's a simple and advanced tab. And if you click advanced, it goes over to this YAML syntax, which is actually what's happening behind the scenes. So semgrep rules are just these YAML files that have a bunch of clauses in them. And so the simple pattern, as you can see here, gets turned into this pattern clause. You can add your own message in the advanced tab and one of the features that semgrep has is the ability to interpolate the meta variables into your message. And so one cool thing that somebody on our team came up with was using this meta variable interpolation to create a comma separated value of endpoints in your web application. And so this example uses the Gorilla framework to set up a bunch of routes for a web app. You can write a semgrep pattern that finds like all the registered handlers and the HTTP verb that it uses, spit those out as a comma separated value, and then you get those in your message, which then allows you to do something cool like this, which was built by one of the members on our team. It lets you, where he put this visualization on top of exactly something like this, except it was for a Flask application, to find all of the endpoints in your application. But then he took it a step further by looking for authorization capabilities. And so he color coded those based on the authorization that's in them. So yellow means that authorization is required. Red means that this route is unauthenticated. Green means that these are administrative routes. And so this is like really cool because when we do like assessments on other people's code, we can come in and like run this visualization and we can immediately find like, oh, here are the unauthenticated routes, and we can start looking at that, which is like really cool. It saves us a lot of time. SemGrep has limited support for auto fixes. And so as much as I was decrying regular expressions earlier, they're still quite powerful. Like they're not necessarily useless. Like they still have their place. And one of those places that we have decided to use them is actually in our autofix. So you can use regular expression replacement within the match itself, which actually ends up being really powerful when combined with like the SemGrep matching engine, because you're normally, if you do like sed replace, you might like accidentally replace a bunch of stuff that you don't want. But because we're limiting it to specifically to the SemGrep match, it actually allows us to be really precise about our auto fixes or our replacements. And so to do replacement, you use this fix-regex key where you specify the thing that you want to replace. And so we're going to replace the deprecated version of SSL with the much more secure version of TLS 1.3. And so you can see over here in the editor, it will give you a nice little preview that's a little squashed because I'm zoomed in right now. But if you click apply fix, you'll see that it just replaces inline, which is really neat and very useful for migrating off of like deprecated APIs or switching function calls or adding or subtracting arguments. The last advanced feature that I want to talk about is that SemGrep is also scriptable. So you can call out to Python using this special clause called pattern-where Python. So if you find that the like syntax that's available to you is not expressive enough, you can always just reach out to a Turing complete language in order to complete your analysis. Of course, for the security conscious, this means that you're reaching out to executable code. And so to use this, it requires setting this very long and very hard to type string, which is intentional, that is illustrated at the bottom. Dangerously allow arbitrary code execution from rules. So it's very long, very hard to mistype, very explicit. You know exactly what you're getting into when you invoke this flag. One of the best examples that for using the scriptable ability is on numeric analysis. So let's say you wanted to find like RSA key sizes that are insufficient. 2048 is the recommended key size, which means 1024 is considered insecure. We can see here that this pattern-where Python clause operates on this bits meta variable, which is in the RSA generate key here. And it will only report if the, so we'll do like integer on the bits meta variable. It will only report if that number is less than 2048, which is what we have here. We have 1024, which is what we want, and 2048 is all good. All right, so that was a lot of demos, but is a whirlwind overview of how SemGrep works. And so what I want to talk about now is how you can use it sort of continuously. So SemGrep is great for searching code. You can do it manually if you want, but its real power is when you use it automatically in like continuous integration or other CI/CD pipelines. So we support a bunch of CI pipelines out of the box. So you can use Git pre-commit if you want pre-commit hooks. We have support for GitHub Actions, GitLab, Circle CI, and some other things that are listed here. But if your environment of choice is not listed, it's very easy to add SemGrep to CI, either as a Docker container or as a Linux binary. And strangely enough, one of the complaints that we heard when we were building the tool was that older SAST systems, so a lot of the commercial systems, like it's really, really difficult to get data out of them. And so we support JSON output, which makes it really easy to integrate with other systems. So you can just output your results as JSON and like pump it to wherever you want. And so this is an example of SemGrep running in our GitHub Actions pipeline. So we use GitHub Actions frequently at R2C. And so this is just a screenshot of what it looks like and what those results would look like from SemGrep. So you can see it's the SemGrep with managed policy, et cetera. And then it has one finding, which I'm going to zoom in on right now. So this is actually really cool because this is the thing that SemGrep detected was a path traversal in a Flask application that we have. And so this is like real. This really happened, and SumGrep detected this real thing on a real issue that we had, and that was on its way out to production. But because we had a rule in place to detect these potential path traversals, SumGrep caught it, which means we were able to review it, which means we were then able to mitigate it. And so this is like really cool because as a security engineer, that means this never went to production. And if it had, who knows how long it would have been there before somebody had discovered it. But because we had SumGrep running continuously, it just never went live, which is a huge win for us. So you may be thinking, SumGrep looks cool, but I don't want to write all these rules myself. Well, we have a community registry where you can go check out the hundreds of rules that we have written for all manner of different languages. I think the last number we checked, we have over 600 rules, many of whom have been developed by us, but we also have a large number that are contributed by community members. Of particular note, a gentleman named Ajahn Abraham, who maintains Node.js Scan, which is a security scanner for JavaScript, has contributed a bunch of his rules. We have ported a bunch of the popular rules from Gosec or FindSecBugs, which is a Java security checker, or others. So those are also available. We have plenty of rule ideas from a lot of notable people. And then another one of particular note is that we have security researchers who go find like awesome bugs and then like come back and write SumGrep rules for them, which is really slick. It works out really well. There are also rules that are floating out, like SumGrep rules that are floating out there that are not in our registry, but one of note is a gentleman named Damian Grisky, who wrote Go Perfbook, has his own Git repository with a bunch of SumGrep rules specifically for Go, and so you can check those out as well. If you want to run some of these rules, it's very easy. All you have to do is point SumGrep at a config URL. And so if you wanted to run Gosec, or the selected rules that we've ported from Gosec, all you have to do is say SumGrep --config equals this URL, and then it will run those rules for you. So it's very easy to do and very easy to get started with. We got a lot more things coming soon. TypeScript I mentioned earlier, many more rules. We're working on a cloud app where you can manage your SumGrep instances from one location, make it easy to do. We have a Visual Studio Code extension that's in beta that will highlight findings for you. So if you're interested in that, let us know. And then we're working on, within the same file, a very basic tainting engine, which will be cool. So that's pretty much everything for my talk. It's very easy to get started with SumGrep if you're interested. You can brew or pip install it and then point it at a config URL like I mentioned. Or if you don't want to install anything, you can just go to the live editor, which is here. So I will end there. If you feel so inclined, please consider taking the survey at the bottom. The survey link is r2c.dev/survey. And yeah, thank you for having me.
Thank you very much for your talk, Grayson. Just going to check the chat. There doesn't seem too many questions, but I have a question for you if you're interested.
Absolutely.
For anyone, sorry, I just noticed there's a question that came in. It says, is there some possibility to add a description that comes along with the findings?
Yes. So the ability to add messages is available in the advanced tab. You can also, like, since SumGrep is just running YAML rules under the hood, you can just make your own rules like on your file system or whatever. And then it follows this YAML syntax. All of this is documented on the GitHub repository. So if you're interested in like looking for them, you can do that. But the relevant one for the question, which is the ability to add a description to your rules, is this message key, which allows you to add a description to the finding. So in this case, it's like RSA keys should be at least 2048 bits, which then shows up over here in the match. And this is the message that it would present to a user if it was being used in the command line as well.
Cool. Thank you very much for the question, Eric. Any other questions? All right. I suppose I'll just quickly ask my question. For someone who's, I guess, maybe new to, I guess, security or things like that, like maybe you're transitioning from somewhere else, like how would you say that you got into it, or how would you get into it? Because it's definitely one of the more niche areas, right?
Yeah, for certain. So security is a pretty wide umbrella. So there's like network security, or there's like penetration testing. Uh, Actually, the place that I started was in protocol analysis, which is very niche and not very. uh, I haven't seen very many jobs in that particular niche. Um, but the sort of the closest one, the closest security subgroup, for lack of a better term, to regular engineering is application security, which is a relatively budding field, probably in the past 4 or 5 years or so. And what application security is it's concerned with the security of your code. And so this is exactly the field that like SimGrep is targeting. So these are the people who are checking code to make sure that it doesn't have any issues when it goes out to production, or who are checking production code to make sure that there are no issues in it. And so that would be my recommendation, is that if you're interested in getting into security, like begin to look at some application security resources. Additionally, if you're interested in sort of participating in a community, we R2C have a community Slack where a lot of people are there. They ask us questions about the tool. We ask them questions about the languages that they're using, because we're not experts in all languages. So yeah, application security, get involved in a community that is relevant to that. That would be my recommendation.
All right, cool. So I'll just quickly share my screen here and present that. But yes, thank you very much
Yep.
for your talk, and thank you very much for your time, Grayson.
Yep, no problem. I saw one more question come in, where it looks like they were running the R2C config, and it looked like it was timing out a little bit. Um, so we have done a little bit of work, actually, since we released the R2C config. And I'm not sure if it's trying to run every rule in our registry, but that might be what it's doing, which means I'm going to put a less intense rule set in the chat, and hopefully you can try that one, and then I will update the slides to make sure that that doesn't happen in the future. So sorry about that.
No worries, always good to answer questions. So I'll just move on. Let's see. So once again, this is where you can contact us and where we will be. You have Twitter at London Gophers. You have meetup.com. You also have our Slack, #London, and we have the YouTube channel, which you currently are viewing. So there's also the #London study group, which is on the Slack channel, where they work through a Go programming language book. So feel free to check that out as well if you're getting started. We have as usual, we have the London Gophers raffle. The code word for this one is WFH. And yeah, because we missed out on August, we'll be giving away 6 JetBrains licenses this time. So, this could be a good chance. And we're going to be going on a quick 5-minute break. And afterwards, we will have one additional speaker, Deep Data. And so for the time being, this is our break conundrums. I'll just leave this up for 5 minutes or so. And yeah, everyone go get a drink and have a nice evening. I mean, we'll obviously come back. There's also one other raffle coming up. There's going to be a Switch being given away. So I definitely stay for that as well. And so, yeah, see you guys in 5 minutes. Okay, I think it's been 5 minutes, but I also forgot to start my timer, but it seems like it's been 5 minutes. So welcome back, everyone. Um, I have a special guest who's going to be doing the conundrum this time. It's going to be Antonio, who, yeah, so I'll just head on over to the slide before the reveal, which I believe is this one. And here we go.
I will ask then Ben to move on with the other slides as soon as as I go, because I don't have control over those. But this is an interesting one because it can be quite obvious to some people who've been through this kind of gotcha before. And we picked this up from the Godoc, where there are the frequently asked questions, and this is a popular one. So what does this print? I saw a few people commenting on YouTube. I see that most people are like thinking about the third or the fourth, so number 3 or number 4, which makes sense, are like almost the correct ones. So if we go on Ben to the next slide, we can reveal, oh yeah, of course, I think, yes, this one. So the key, when I took my driving test, I remember the teacher telling me the key to the answer is in the question. So here we are saying what does definitely print, like all the time, like deterministically, how can you know? So the thing is, in this specific case, is none of the above, because in theory, we will see most of the times the third one, CCC, and the reason is going to be explained just after this slide. But what happens here is that if we go on to the next slide, yeah. So what happens here is most people might expect to see ABC. But the documentation as well says you will probably see CCC most of the times. And the reason is that for each iteration of this loop, we are basically reusing the very same instance of the variable v. And therefore, each of those routines is actually sharing the same single variable. And that means the only time where you know what is going to print is when the print line is executed. But depending on how long is that, for example, range, how long it takes to spin up all the Go routines and to call the print line, you might see different like results. So in theory, we will often see CCC, but definitely none of the above. So if we go to the next slide, there are like a couple of, let's say, standard solutions that are quite common, and are these two. The first one suggests to pass the variable as the argument of that closure. So you can see that in the first, like on the left-hand side, we have nothing. We're just using the closure as it is and reusing that v variable. While on the right-hand side, you can see that we're now passing that and saying that this function, this anonymous function, is accepting a u, a string named u as a parameter, and we're passing that with v, so directly. So at this point, internally in the print line is going to use that u, which is basically a copy of that v. So we know that is exactly the value that we were expecting. So this will be A, B, and C when it prints. The other way to do a very similar thing is just to declare explicitly a new local variable which within that iteration. So this is quite common, and sometimes during code reviews, people might think that is probably something that you forgot in your code, but actually it's doing something. And in this case, we have two v. One is the outer one and one is the inner one. And the inner one is the one that is going to be printed and is a copy of the outer one. So these two approaches are quite common. You will see it often when in this specific scenario. The second one is the one that I see more often, even though I find the first one easier to understand, especially for people who are probably new to the language and might not easily, spot that, v equals v. Another interesting thing to the next slide is that while we were preparing this conundrum, we read that in this doc for the frequently asked questions, below this solution, they suggest that this behavior of the language of not defining a new variable for each iteration may have been a mistake in retrospect, and it may be addressed in a later version, but for compatibility, it cannot change in Go version 1. That was interesting to read. So hope you enjoyed this one, and that was useful for everyone, and a nice refresher for people who already knew about that, and something new and interesting for people who didn't know that. So thank you very much. Over to you, Ben.
Thank you very much, Antonio. So once again, just WHF for the JetBrains raffle. And as I promised, there's one more raffle coming up. So Ari, take it away.
Thank you. I appreciate it. Well, hi, everybody. My name is Ari Waller, and I am the Meetup Event Manager for JFrog, the makers of Go Center. And it's really great to be here tonight as a sponsor for the London Gophers. JFrog is a software company in the Silicon Valley, known by many in reference to our flagship product, Artifactory, which is the world's first universal binary repository. We have 600 employees and 10 offices globally, and more than 3 million developers use our tools on a daily basis. But what a lot of people don't know is that we have an entire software engineering team that primarily develops community-based software in Go. Now, I'm not going to go into a lot of detail on that right now, because that's something that Deep will get into in his talk. But we're just very, very excited to be part of all the great things that London Gophers is doing. So tonight we do have a special sweepstakes giveaway specifically for the London Gophers. This is going to be for a Nintendo Switch Lite. It is going to be given off in the sweepstakes, and there's a QR code there along with a bit.ly link, which I will actually put in the YouTube chat in just a couple moments. So you can sign up there. But with this particular link, you're gonna you can enter, and one person is going to be selected in the next 1 to 2 business days as our winner. They're also going to be selected 5 additional winners who will receive a JFrog Go Center T-shirt, a Gopher T-shirt. So we're excited to give those away as well. So we're very, very happy that to be here tonight. And again, we'd love to see as many of you get that Nintendo Switch Lite. If you've looked for one in the stores, you have to get to the big box stores very, very early to find these things. I guess I go a little too often because I was able to snag about 5 last month. But even the employees couldn't understand how I found these. So anyway, they're going away quick, and we're happy to give them to you today. So 1 selected winner for that, and 5 T-shirts. And I'll turn it back over to you. And thanks again, Ben.
Thank you very much. So good luck, everyone. Hope you get the Switch. And next up is going to be Deep Data, who will be talking about security of Go modules and vulnerability scanning in Go Center. So over to you.
All right, thank you. Okay, so let me go ahead and share my screen, and I'm just going to have someone wave, make sure you can see my screen okay. It's all good? Okay, great. All right, guys, so I'm pretty excited to be here, talk to you a little bit more about Go Center and how security in Go modules work. So I'm just gonna kick right off, and basically for today's agenda, going to do a little introduction about who I am. Then we're going to talk a little bit more about dependency management and some of the changes that came with Go 1.13. We'll talk more about specifically how Go modules evolved. I'll do a little bit of a deep dive into a few concepts around the checksum database that helps you verify your modules. Then I'm going to show you an example of what it might mean to commit a new module to that checksum database, and where security and data integrity plays a part in that. Then we'll actually go look at Go Center, which I'll dive into much later, and I'll show you how the vulnerability scanning works on Go Center. We'll wrap up with some Q&A. I'll show you a little bit of what we're doing in VS Code. And of course, we'll end with just a conversation around what we're working on here at JFrog. Okay, so my name's Deep Data. I am the community-focused product manager at JFrog. So my job is actually a lot of fun. I get to work on all the really cool sort of cutting-edge community, fun, free, open source adjacent tools. And one of the products that I manage is Go Center, which is a module mirror for Go. I'm a huge fan of working directly with developers and communicating with you guys. So please do contact me if this talk was interesting or you have other ideas about what we're working on. My email is deepd@jfrog.com. You can also tweet at me. I'm pretty active on Twitter. And let's go. Okay. So this is a Go meetup, so most of you have probably been involved in the Go language for a little bit now, and you probably know that Go has gone through a few different concepts in dependency management. So there was a concept we went through called Glide. It had we also asked users to place their project folders inside their Go path to resolve packages. Then experimented with a dependency management tool called DEP, which is great because DEP is one letter away from deep. So that one was my favorite. But as the community involved, Go's leaders found that there was a better way to manage packages. And in Go 1.11, this concept of Go modules was introduced. And a Go module is basically just a collection of Go packages stored in a tree stored in a file tree with a go.mod at the root. And then in the Go 1.13 release last year, Go modules became the official standard. So what I really like about Go modules with the 1.13 release is how much thought the founders put into making sure that the data stayed intact in transmission and storage. So when I do a Go mod init, your Go mod file gets created, and you also get this file called go.sum, right? And the go.sum file is where your checksums are stored. So these checksums, they're hashes. So basically, a checksum is a way to verify that a piece of digital data hasn't, changed or been broken or been hacked. And the kind of checksum that Golang uses is a SHA-256 base 64 hash. And that's what you're looking at here stored in the go.sum file. With Go, this basically makes sure that it's a digital handshake, and it makes sure that any data that I put in my module that I want to verify that you got later down the line, what the checksum actually does is Golang built a database where these checksums are stored. So if I am importing a module at a later time, it'll actually use this list of hashes in your GoSum file, and it'll verify that my list of hashes is the same one that the author intended. And I'm going to talk a little bit more about how that works in practice. But before I do that, I want to dive into, a little bit of a deep dive into what a SHA-256 hash actually is. So, your GoSum file has these hashes in it, and the SHA hash, it stands for Secure Hashing Algorithm. It is basically the one that has become the de facto hash. It hasn't been broken as of yet. And generally, the way the hash is, you put a piece of data as the input, and then through a bunch of fancy math and hashing algorithms, it spits out a 43 character string. And a single character difference in the input can spit out a completely different looking hash. So if I have a plain text file or an image or an entire application, and I make one change to it, one tiny character change, when it is hashed, the output can look completely different. This means, this is great because then these hashes they're very difficult to mimic or reproduce in a hacky way. And the other thing about hashes that are really cool is that they're irreversible. You can't have the output and then reverse engineer and get the input. And again, they're also unique because the minute you change one little thing, the entire hash changes. So this is really important to how Go actually verifies your modules in the checksum database. So Golang has a database. It's where the Go modules information is stored. And the checksum database that Go uses uses a Merkle tree structure. So Merkle tree is something you may have heard about from blockchain. But basically, a Merkle tree is a tree of hashes, right? So at its core, it's a list of items that represent the data. And what happens in a Merkle tree is each piece of data is hashed, and then those hashes are hashed again all the way up to the top, which is called the root node. This is a really effective way to keep data integrity intact. The reason is if one piece of data changes at the bottom of the tree, let's say, it changes that hash, which changes the hash, up that branch all the way to the top. This means that you no longer have to scan the entire, the entire Merkle tree to verify that something has changed. Since the root hash changes when any other part of the branches change, you'll know right away just by checking the root that some piece of data is no longer, what was originally committed. The Merkle tree structure also makes it really easy to see where in the tree that change was made. So if somebody tries to inject something in this Merkle tree structure, it'll be very easy to understand where it happened and when, right? So this is the way that Golang actually stores the Go module data. They store the Go sum files this way. And again, it just makes it very easy to check the integrity of your module. Okay, so in this example, if I have two totally different modules, right? Call it module 1 and module 2. Each module has its own independent Go sum file, and each Go sum file has a list of the SHA-256 base 64 hashes. And because these are different modules with different Go sum files, they are stored in the Golang checksum database, and they're good to go. So now that they're committed, anytime somebody imports that module at a later time, it'll check the Go sum file, and this is how it'll make sure that the integrity of the file hasn't changed. So now, if I actually go and I make a minor content change to module 1, what's going to happen is my go.sum file for module 1 is going to change, and I'm going to have a totally different list of hashes. And because of that, module 1 can no longer be verified with the Golang database, and you're going to get a checksum mismatch error. So what this does is this really protects you both as an author and a consumer of these modules to know that you are getting the module that was originally committed. Okay, so let's dive a little deeper into this. Let's say I create my first Go module, right? And I save it as mod1. Obviously I get a go.mod file generated, and then my go.sum file has the list of hashes. But as I'm creating this module and saving it and building it and committing it to the Golang database, I notice I made a mistake. Here I imported the text/template package, and in itself, this package is not error prone necessarily, but the text/template package actually does not encode or encrypt my data, and this application is going to be sending data to my browser. So by using the text/template package in this example, I am opening up my application to a cross-site scripting attack. So I have created my module 1, and I have this little issue in the imports, and I've already committed this module to the Golang database. So what do I do? Well, obviously I can fix my file, and I can import the right package, the HTML/template package. This will add my web browser, my data in the web browser is encoded. But if I try to save this mod 1 as the exact same version, I'm going to get that checksum mismatch error because my data has changed, and that means my list of SHA values has changed. So what I actually need to do is I need to save this new version of mod 1 as a new version, and I can do so either as a patch or just going along with this example. If I make a major change to this module, I can save it as a v2. When you do save your Go modules, I do want you to pay attention to semantic import versioning. So if I'm just doing a minor patch version, then I can basically update that version as a v1.1.1, and the syntax, the v is connected to the end of the module name. But one thing I want you to notice is if I am doing a major change and I am committing this as a version 2 of my module, there is a different sort of syntax, right? Now there is a slash that has gone in front of the v2. And Go is very strict about versioning. So if you are saving your modules, as a v2, just remember this semantic import versioning rule, and you'll be fine. Okay, so now I have my mod 1, and I have my mod 1 version 2. And because I've versioned them correctly, they have their different list of SHA values, and the Gosec file can actually commit itself to the database, and I'm fine. So in this case, now that I've versioned the application, I'm not going to get that checksum mismatch error, right? All right. But what happens if somebody accidentally imports mod 1? Maybe I wrote a blog about it and I forgot to update the blog. Well, they're going to open themselves up to the cross-site scripting attack that I talked about earlier. And the reason that this matters is because in the real world, when you have a Go application with a list of dependencies, those dependencies are being updated all the time, right? You don't know when a new version of your dependencies might have an error introduced or a vulnerability introduced. And so again, the thing that we really want you to sort of understand here is that these vulnerabilities can be introduced in modules that are totally new. They can also be introduced in an old module with a totally new version. And I'll talk a little bit about what we're working on at Go Center to solve that problem. So just to summarize so far, the Gosec file has your list of hashes. The Go mod file stores, the list of your dependencies, and these hashes are basically used to check for misbehavior. However, again, if the module was committed and maybe it had a vulnerability from the start, the Golang database is not going to know that, right? So we have built vulnerability scanning into Go Center. Go Center is a module mirror. It has over 740,000 Go module versions and counting. It's completely free, and it always will be. It's a place where you can go get any module in any version. And we have every publicly available module. You can actually just use Go Center by setting your environment variable export Go proxy to https:/gocenter.io. And I'm going to show you a little bit of a demo now of what we're doing on Go Center to keep your modules safe. So let me reshare my screen. Oh no, actually I have it up here in this browser. All right. So this is Go Center. This is our community-focused proxy for Go. And what I'm going to do is I'm going to go ahead, I'm going to search for a module that I know has a vulnerability. So when you search for a module here, what you can see is you're going to see the module name. You're going to see a little description about the module. You'll see the latest version, including any pseudo versions. You'll see downloads and stars. When I go ahead and I go to the module page, Go Center has a lot of metadata about the module. So we tell you the stars, the license, the downloads. But what's really interesting for today's talk is the security tab. So on the security tab, what I'm actually seeing here is This specific module, Moby, this latest version of Moby has 4 vulnerabilities. We show you the severity level of the vulnerability, and we give you a little color indicator. It can be red, orange, or yellow that corresponds to the severity level. We provide you the actual CVE ID. This stands for the Common Vulnerabilities and Exposures List. This is a public database. You can Google this CVE and find out more information. But we also give you a brief description about the CVE. And what makes this really important, if I can go back to my presentation, is if because we scan every module proactively, if you are using my mod 1 that I committed and you don't know that it has a vulnerability, GoCenter will actually alert you that it does. And then GoCenter can actually also show you what versions of this mod 1 are vulnerable and what versions do not have a vulnerability. So this is actually how we keep your Go modules safe. The last thing to sort of tell you about this is, GoCenter uses JFrog's premium security scanning tool, X-Ray, and we provide you all this publicly available security data. So what I'm showing you here is, again, the common vulnerabilities and exposures list. This is a screenshot of real CVEs that apply to the cross-site scripting issue I told you before. And one really cool thing that we released earlier this year is GoCenter's vulnerability scanning in Visual Studio Code. This has probably been one of the most impactful things for me personally as I'm building my applications in VS Code. And I'm gonna reshare my screen so I can show you a tiny bit of a demo of exactly how the VS Code extension brings in the GoCenter data. Okay, so share my desktop. Okay, so just to kind of walk you through an example of how you would actually use the Visual Studio Code extension. I come from the world of web development, and one of the first things I tried to learn when I sort of moved over to learning Go was how to build a web application with Golang. So I have this little grocery Go app, and the idea here is that my parents can add items to this application, and then I can go out to the grocery store and I can buy food for them. So in my little grocery Go application, I can go ahead, I can add an item. So, or let's say it's my dad. My dad wants to add an order to our Go app. So my dad really likes soda, and the kind of soda is Pepsi, right? So in my in the web browser, what you're seeing is this information has been added. As I was building out this application, what you're looking at is the front end. And what I did first was I used a tutorial to build the front end and save the data to a local file. But the next thing I wanted to do is connect the front end application to my back end. So using another tutorial, I actually found a object relational mapper called GORM, and I'll show you a little bit of that in a second. And what GORM does is it maps the front end data in my Go application to any database that I want to use. So in my tutorial, I used Postgres. And here in the code, you can kind of just do a quick scroll through the code. You can actually see I'm saving the data to signatures.txt, and then I am creating the routers here and launching it in my local host. And this is the front end. And then for the back end, using GORM, I mapped the information to a database. And the place where the vulnerability scanning comes in is, as I was building my GORM application, one thing that I was alerted to in my Go mod file was that the version of GORM I was using was actually vulnerable. So what you're seeing now in my Go mod file is the GORM module, And you're going to notice it's got this little yellow squiggly line underline, right? And the reason it has that underline is because there's a vulnerability in this module, version 1.9.9. So what's really cool about the JFrog extension is we're giving you this vulnerability scanning from GoCenter for free. When you mouse over the module, you get this little box of information, and you can see vulnerabilities high 1. And one other really cool thing I can do is I can, on the very left, I can actually dive into the component tree and see more details about those vulnerable components for this module. And then the best thing about using the JFrog extension is I can hit upgrade dependency, and it'll actually upgrade it to the latest version. So when I do that, it's going to start upgrading all my dependencies to the latest version, and then I can do a go mod tidy, and I can clean that up. If it wants to work, it would clean up. Okay. All right. So mainly I wanted to show you the vulnerability scanning, and I'm going to go back to my presentation now. So if you do want to check out Gorm, those are the links right there. And that's the API tutorial of the front end. GoCenter is something that we're really proud of at JFrog, and we're working hard to make your modules safer and provide you that information in the UI. So again, if you want to learn more about GoCenter or just talk about what I just showed you, please email me or tweet. And that's basically my presentation. I'll take Q&A, and I promised Ari that I would put up this slide at the end. So if you want access to the show notes, you can actually go to that bit.ly link at the bottom. And of course, if you give us your information, you're going to be entered to win the Nintendo Switch. So that is my presentation. Any questions?
I suppose I could ask a question.
Sure.
It's a bit of a okay. Generally, like what would you say are the most common questions that come up around this? I mean, like that question's sort of a cop-out, but since you've done this talk so many times, I'll just
a lot of people start asking questions about the capabilities of our vulnerability tool, and I explain to them that that the tool itself has a lot that there's a lot of advanced features you can get, but that those are in X-Ray. Those are JFrog's premium solutions. One of the other questions I get is if there's like an API so that you can build this vulnerability information into your own sort of tool set. Again, because this information comes from X-Ray, if you have a subscription to X-Ray, you have options like that. So those are some of the questions we get.
Cool. I was just resharing the screen so you can see the rest of the slides. Let me just check the chat. Well, I suppose that's all for questions. But once again, thank you so much for coming down, and thank you so much for sharing the talk. I find it quite interesting, and thank you for answering the common questions that come up. And we appreciate your time here. Thank you.
Awesome, appreciate it.
So the next London Gophers will be in October. Keep it online for the time being. We'll also assume that November might also be online as well. Like we'll always keep it posted if things change, but for the time being and looking at how things are going, it's most likely it's the safest option. And yeah, as in like, I think this is a way to sort of just, if you want to go on London Gophers afterwards and like hang out with anyone who is here, feel free. Unfortunately, there's no pub because, well, we don't have that. This is all online. But yeah, thank you so much for coming along. Once again, thank you to our sponsors, which is Tyke and JFrog. Thanks once again for the raffle as well. And I hope everyone has a good evening, I guess. Thanks everyone. Thank you for all our speakers. Thank you for your time. And yeah, see you next time on the next London Gophers. See ya.
See you.
Bye.
Thank you.